Good day, grade 12 learners. Welcome to today's Life Sciences lesson. My name is Agnes Muabelo. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. On the screen, there is a number that is reflecting there. I'm going to read the number where you're going to text your messages. So we only take text messages and not videos and not voice calls. The number is 079-578-2908. I'm going to repeat the number 079-578-2908. Right. Today's lesson is on meiosis. And I can't emphasize enough how important the exam guideline is. This exam guideline informs you on everything that is going to be examinable. Now, the topic meiosis takes 25 marks. It is allocated only 25 marks of your paper 2. So you really need to excel on this meiosis. I know last session we did meiosis where you were able to differentiate between replicated and unreplicated chromosomes. You also discussed the different stages of meiosis. Remember, with the stages of meiosis, it is important to know all the events that are happening in each stage of meiosis. You also differentiated between meiosis 1 and meiosis 2. Now, with life sciences, this is a strategy to say with all our structures, you need to know the structures. You need to know the functions of the structures. So same with meiosis 1 and meiosis 2, you need to know the events that are happening in each stage. For an example, you need to know what is happening in anaphase 1, anaphase 2, metaphase 1, metaphase 2, telophase 1, telophase 2. So all those phases are important learners. Now for today's lesson, I'm going to continue on meiosis. We're going to discuss non-disjunction and Down syndrome. Now, according to exam guideline, this is important also to give proper definition of meiosis. So meiosis is a cell division whereby a diploid cell undergoes 2 cell divisions and divides to form 4 different haploid cells, or those haploid cells, we can call them the gametes. Now I'm going to show you diagrammatically what happens when meiosis takes place. Take for an example, we are saying it is a cell division whereby a diploid cell undergoes 2 cell divisions. Can you see that? And those 2 cell divisions are going to form 4 different haploid cells, or you can call them the gametes. So this is the definition of meiosis. You need to state it exactly as it comes from the exam guideline. I know you've got resources that were given to you by the teachers. You have Mind the Gap. You have the study guides, 5 of them for each topic in grade 12. You have the DBE textbook, which is electronic. You can use all of those in conjunction with the exam guideline. This will definitely assist you. Now, we are going to do consequences of abnormal meiosis. What is going to happen should meiosis go wrong? What are the results of abnormal meiosis? So some of you do not know what non-disjunction is. Now with non-disjunction, it is the failure of chromosomes to separate during meiosis. Now, during meiosis, immediately when chromosomes fails to separate, you must know that non-disjunction is taking place. Now, non-disjunction can happen during anaphase 1 as well as in anaphase 2. Let us check. In anaphase 1, what happens? The homologous chromosomes may not separate. It's important to indicate that the chromosomes are in their homologous pairs. So what we are saying in anaphase 1, the homologous chromosomes may not separate. What about in anaphase 2? In anaphase 2, when the sister chromosomes or when the sister chromatids do not separate. So it is also important, like earlier on, I've indicated that in terms of the phases of meiosis, you need to be specific to say what happens in anaphase 1, what happens in anaphase 2. So if you don't mention whether it is 1 or 2, you might lose the marks there. Right? Now, like I was saying, I'm going to explain what is non-disjunction. So, non-disjunction can cause normal meiosis or abnormal meiosis. Take for an example. In this cell, remember we have defined meiosis, whereby a diploid cell is going to divide into 2 haploid cells. So in this case, meiosis is normal because the haploid cells gives half the number of the original cell. Now when meiosis 2 takes place, check what is going to happen. Chromosomes will be separating. We're going to have one this side, one this side. Chromosomes will be separating. We're going to have 2 chromosomes this side, 2 chromosomes this side. So in this case, after meiotic division has taken place, what is going to happen? We're going to have the formation of 4 different cells, 4 different gametes, and this we call normal meiosis. Now let's check what happens in abnormal meiosis. In abnormal meiosis, check this one. The original cell has got how many? 2 pairs of chromosomes or 4 chromosomes. So after meiosis 1 has taken place, what is going to happen? Remember, the original cell gives rise to 2 haploid cells. The original cell, which is diploid, is going to give rise to 2 haploid cells. Now, when non-disjunction takes place, look at this one. We had 4 initially or originally, but the haploid cell is having what? 1, 2, 3 chromosomes. In the other cell, we've got how many? We've got 1. So this means there was non-separation of chromosomes. Check after what happens when meiosis 2 takes place, has taken place. Now, from this cell, we're going to have 1 chromosome in 1 cell, 1 chromosome in 1 cell. And this is abnormal, right? From this other haploid cell, we're going to have the 3rd chromosome here on this cell and also the 3rd chromosome here on this cell. This means the meiosis in this case is abnormal. Why abnormal? You may ask yourself, why abnormal? It's because chromosomes failed to separate. And when chromosomes are failing to separate, we call that non-disjunction. Let us look in the other abnormal incident, whereby the diploid cell undergoes meiosis 1 and it will give rise to 2 haploid cells, each carrying half the number of the original. Then meiosis 2 takes place, and then we're going to have what? 1 cell with 1 chromosome, the other one with what? 3, the other one with 2, 2. So in this case, these 2 undergoes normal meiosis because the results carry half the number of the original cell. But check at this 2. This is abnormal division because we don't get what? half the number of the original cell. Now, we've spoken about, or I have introduced, non-disjunction of chromosomes that is taking place in anaphase 1, or it can take place in anaphase 2. So, non-disjunction in anaphase 1. Let's check. The original cell has what? 2 chromosomes. Then check, because the diploid cell should give rise to 2 haploid cells. In this one haploid cell, we've got how many? 2. So this simply means this is non-disjunction, because if you look at the 2, compare this one and the original one, it still has got 2. So it means non-disjunction did not take place. It means chromosomes did not separate. Look at the cell. There's nothing. And then normal meiosis take place. Now, when normal meiosis take place, check the haploid cell had chromosomes separating here, each cell having half the number of the original. But if we look at this one, there's nothing. Okay, so what we are saying here, non-disjunction can take place in anaphase 1. Now we're going to compare non-disjunction in anaphase 1 and anaphase 2. Right, now non-disjunction during anaphase 1, we have looked at that. So in anaphase 1, 2 cells will have an extra copy of chromosome. 2 cells will have an extra copy of chromosome. And what is going to happen? 2 cells without chromosome. So if you can check, 2 cells will have an extra copy of chromosome, and 2 cells, they are without chromosomes. Therefore, all cells are affected. Now in anaphase 2, non-disjunction in anaphase 2, so the original cell will have diploid chromosomes, and it will divide through normal meiosis, whereby when normal meiosis takes place, we know the haploid cells each is going to have half the number of the original cell. So let's look at this haploid cell. Now with this haploid cell, let's check. Did separation of chromosomes happen? No. Now, when chromosomes do not separate, please, girls and boys, you must know that there is non-disjunction. Chromosomes did not separate. Now, in this case, remember, originally we had 2, then normal meiosis has taken place, then we've got 1 here, then normal meiosis further taking place in meiosis 2, then we're going to have what? 1 haploid cell giving rise to 2 cells, each cell carrying half the number of this one. This is anaphase 2. Right? Now, non-disjunction in anaphase 2 results in what? It results in 1 cell without a chromosome. It results in what? 1 cell with an extra chromosome. So, non-disjunction in anaphase 2, it will result in what? Can you see this cell? It is a cell without a chromosome. Can you see this one? It is 1 cell with what? An extra chromosome. Okay? I'm going to further explain non-disjunction. Don't forget, in your mind, immediately when you talk about non-disjunction, please note that we're talking about the non-separation of the chromosome. Now, let us check this one. When it takes place in anaphase 1, both cells are affected. This is haploid, original one. Both cells are affected because of what? Non-separation of chromosomes. Okay? Right? And all 4 gametes affected are affected at the end of meiosis 2. Check. After meiosis 2, let's take this 1 haploid cell first. Now this one is going to divide into 2 cells. There's nothing there actually happening. And then with this one, because it has got 2 chromosomes, when normal meiosis has taken place, check, it has divided into half of this, Therefore, on my right-hand side, this haploid cell gave rise to this. Now listen to this one. All 4 gametes are affected at the end of meiosis II. Check the 4 gametes. We are saying they are affected. Now, when the affected gametes, when the affected gametes fuses with normal gametes, so this will be a normal gamete from a sperm cell. This is a normal gamete from a sperm cell. This is a normal gamete from the sperm cell. So when the affected gametes, which are these ones after meiosis II, when they fuse with a normal gamete, the zygote will either have one less chromosome or one extra chromosome. Let us verify that. This is the affected cell. It fuses with the sperm cell. Can you see there's nothing inside here? But in the sperm cell, we've got what? 1 there. So when this gamete fuses with the affected cell, it forms what? We've got 1 here. Can you see? Same applies with this haploid cell. When it fuses with this normal cell, here we've got 1. On the right-hand side, on my right-hand side. So this cell is affected when it fuses with the sperm cell. Can you see that? We've got 1, 2 here. We've got the 3rd one here. Then the results, the zygote is going to have 3 chromosomes. Check the last one. We've got 2 here. And then from the sperm cell, we've got 1. Then when this sperm cell, which is normal, fuses with the affected gamete, what is going to result? We're going to have then 1, 2, 3 chromosome. Okay, now let's read this statement again, because most of the examiners like it when you are explaining what non-disjunction is. So we are saying at the end of meiosis II, when the affected gametes fuse with the normal gametes, the zygote will either have 1, we have proved that. The zygote will either have 1 less chromosome or 1 extra. I hope this makes sense, grade 12 learners. Now, let us check on this side. When it takes place during anaphase 2, remember I was explaining anaphase 1. Now when it is taking place during anaphase 2, what happens? This is a diploid cell giving rise to 2 haploid cells. And the way it is happening after this meiosis 1, it means this is normal meiosis, because the haploid cell each carry half of the original cell. Now let's take on my left-hand side. With you probably is on your right-hand side, but let's check on my left-hand side. Now we had 1. Do we see any separation of chromosomes here? No, there's nothing here, but in here we've got 2. So this means this is abnormal meiosis, right? On the other hand, of the other haploid cell, it is giving rise to 2. Is this normal meiosis or not? Yes, this is normal because this is carrying half of the original. Now, let's check. We've got cells being affected there. Now, when you see this sperm cell, it has got 1, it has got 1, this one has got 1, this one has got 1. So when this normal gamete fuses with affected, it is going to result in 1 less chromosome. Let's check the other one. Here we've got 2, and then 1 from the normal gamete. Then when they fuse, when this normal gamete fuses with this one, we're going to have 1, 2, 3, right? And then these are the haploid again fusing with the sperm cells. We're going to have what? 2, 2. So this side we've got normal meiosis taking place, and on this side, we've got abnormal meiosis taking place. So only two gametes are affected at the end of meiosis 2. Can you see that? And also, if you look at this one, when there is Down syndrome, it is the result of what? Non-disjunction. So simply we can say non-separation of chromosomes can lead to Down syndrome. Simply we are saying when chromosomes do not separate somewhere, I'm going to tell you where, then it will cause what? Down syndrome. Now, in meiosis 1, anaphase 1, the chromosome pair 21 does not separate. So remember, each person has got a karyotype where pairs of chromosomes are placed. Now remember also that each person has got 44 body chromosomes, which are autosomes. We can also say it is 22 pairs of chromosomes, body chromosomes. But then on the last pair, which is the 23rd chromosome, we've got what? The sex chromosomes, the gonosomes. Right? Now, for a female person, we're going to have what? XX on the 23rd chromosome. And for a male person, on the 23rd chromosome, we're going to have what? XY chromosome. So, in meiosis 1 and anaphase 1, the chromosome pair 21 does not separate. Or in meiosis 2 or anaphase 2, the chromatids of chromosome 21 do not separate, or centromere does not divide. So you can make it easier for you to say in anaphase 1, we're talking about the chromosomes, whereas in anaphase 2, we're talking about the chromatids. So when chromosome 21 failed to separate, we refer to that as non-disjunction. One gamete will have an extra copy of chromosome number 21. If this gamete fuses with another normal gamete, which is 23 chromosome, the resulting zygote will have 3 copies of chromosomes 21 instead of 2, or we can say we have 47 chromosomes in that karyotype instead of 46. Remember, I spoke about 44 chromosomes, 22 pairs. I'm also speaking about the 23rd pair. So all in all, we've got 46 chromosomes. Now, what will happen if a person has got 47 chromosomes? It means somewhere in chromosome 21, the chromosomes failed to separate. Right? And this, immediately when we've got 47 chromosomes, immediately when we've got the third chromosome on chromosome 21, this will lead to Down syndrome. All right? Now, like I earlier explained, that we've got a male and a female individual in terms of in case of people. Now, all this set of chromosomes are placed where? In a karyotype. Now, 44 pairs are autosomes, and the last pair, for in case this one, we've got XY. These are gonosomes. So it means this individual is a male. And then with this one, on this karyotype, we've got set of chromosomes. Can you see those? They are 44, and we call those the autosomes. And the last pair is XX. XX means gonosome. This is very interesting because also you can go to the public places, sometimes to the bathrooms, they don't even write male or female. You can have these symbols only. This symbol refers to a male, this symbol refers to a female. So we can only identify the male and the female looking at what? The last pair of chromosomes, which is XY and XX, right? Let's continue. Now remember, we have indicated that non-disjunction can lead to Down syndrome. What is Down syndrome? I've spoken about the karyotype, which is having 46 chromosomes. Now I'm going to literally count these pairs to check how many they are. Remember, we are looking at the karyotype of a Down syndrome at the moment. This is one, they are even written. It is made easier for you learners. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Check. On 21, all of a sudden we've got 3 chromosomes extra. We have an extra one. Then 16, 17, we've got 22nd chromosome. Then we've got the last one, which is XX. So it means this person with a Down syndrome, it's a female because the last one we've got what? XX. And then on the 21st chromosome, we've got extra 1 chromosome there. So it means we're no longer having 46, but 47. So in this case where we've got extra chromosomes, because of the non-disjunction of chromosomes, because chromosomes failed to separate in this chromosome 21. So this leads to the Down syndrome. Now let's check. If a gamete or ovum with 2 copies of chromosome 21, right, this one is fertilized by a normal sperm cell, what is going to happen? The zygote will have 3 copies of chromosome 21, as you can see here. So individual will have what? Down syndrome, and the other name for Down syndrome, we can call it trisomy 21 because we've got 3 chromosomes on pair 21, on chromosome 21. Now, people with Down syndrome, girls and boys, we really need to embrace them because it is not their choice. They did not choose to have this genetic disorder. So Down syndrome is a genetic disorder. You can't tell whether you're going to be or you're going to have Down syndrome or whether you're going to have this condition. Now I'm going to show you symptoms of Down syndrome person or individual. Now, if you can check there, the person will have small oblique eyes, okay? Also, you can tell with what? Flattened nasal bridge. Can you see? The nasal bridge is flattened there. And also open mouth. It's not their choice to just open the mouth. Protruding tongue also. If they had a choice, they wouldn't, right? We've got broad neck. Look at the neck, it's broad. And these people, we are living with them. You've got them in your families or in your friends' families or in your neighborhood. Let's respect them. Let's love them. Now, also, we can you see this fold? It also tells what? That this person might be having a syndrome. And small underdeveloped ears also, it's a symbol, it's a sign that this person might be having a Down syndrome. Remember, if we are quickly going to recap, Down syndrome is the result of what? Non-disjunction. And non-disjunction, think of what? Non-separation of the chromosomes in pair number 21. So I'm going to pause now. This is the end of meiosis, where we were looking at the non-disjunction that leads to Down syndrome. I'm going to hand over to Nonhlanhla, who is going to do the questions with you. And girls and boys, you really need to, attempt those questions. because most of them, they are possible questions that you can get in the exam papers. So you also need to revise through all the sections. Any topic that you are doing, you go to past papers, you go to 2020 papers, 21, 22, 23, revise. Get used to those action verbs. Get used to those action verbs to ask you on what to do, on how to answer. You know what? Yeah, I'm going to hand over to Nonhlanhla, and thank you very much. Please make sure that you study very, very hard, because this is this is a short year, and for you mastering the topics, looking at the mark allocation, it can help you. I thank you.
day, grade 12 learners. Welcome to the second part of today's lesson, which is life sciences. My name is Nonhlanhla Mtshali. Remember to send your questions via text message to 079 578 2908. I'm going to repeat the number again. It is 079 578 2908. So just like Agnes has mentioned, on the first part of the lesson, we were looking at meiosis and non-disjunction and its cause on and Down syndrome. So now we're going to move on to the activities, because it is very important that with every content that we go through, we must do at least 5 or more activities per session before we move on. We always highlight that. So you get as many past question papers as you can, you go through them so that you see how it is asked and you respond, so that you also gain confidence in how you respond to the questions. So we're going to look at activity number 1. Here we're looking at the diagram. There's an instruction which says, sometimes an error occurs in oogenesis, resulting in an ovum which carries an extra chromosome. So it says sometimes an error occurs in oogenesis, resulting in an ovum which carries an extra chromosome. So you learned about meiosis. Meiosis takes place where? In the reproductive organs. It results in the formation of what? Of gametes. So we're looking at oogenesis, which takes place in the female reproductive organs, where it results in the formation of what? Of an ovum. But then in the males, we call it spermatogenesis because it results in the formation of the sperm cells. So this is what we learn in meiosis. We're still going to come across this in the next topic, which is human reproduction. So then here we are told that part of such a process is shown in the diagram below. So if we look at the diagram before we look at the questions, because we always say to you, study the diagram, make sure that you understand the diagram before you attempt any questions. So let us look at the diagram together. We have a diploid cell here that has 44 plus XX, and then we have stage 1. And then after stage 1, we have 2 cells which are now what? Haploid. And then after the end of stage 2, we have how many cells? 1, 2, 3, 4. So now let's look at what is happening in these cells. We know that the process that is taking place here is meiosis, because we started with 1 cell that has resulted in how many cells at the end? 4 cells that we call the gametes. Now, if you go back to stage 1 or into the first cells, it has 44 plus XX. So the 44, remember, these are autosomes. And the XX, this is the gonosome. And the fact that it is XX, we know that this cell refers to a female cell. Also because we were told that this is oogenesis, and we know it is in the female reproductive organs. Then at the end of the phase number 1 now, or stage 1, which is meiosis 1, what are we looking at? We're looking at 2 cells. So one cell has X plus 21, and the other cell has X plus 23. Already, you can now tell that something has taken place here. Failure of the chromosomes to separate has taken place, because we should be having 2 cells that each have 22 plus X, 22 plus X. But instead, we have X plus 23 and X plus 21. So there was the failure of the chromosomes to do what? To separate. And then at the end of stage 2, we have 4 cells, of which 2 have 23 plus 1, and 2 have 21 plus what? Plus 1. So just like Agnes indicated earlier, if a non-disjunction takes place in anaphase 1, all 4 cells, all 4 of them at the end, will be abnormal cells, because 2 are going to have 1 less chromosomes. We're looking at this, and 2 are going to have 1 extra. So this, we know that this is anaphase. It took place in anaphase 1. So now we've analyzed the diagram. We've probably answered some of the questions before we can even see what those questions are. So now let's look at the first question. It says, name the stage 1 in the diagram. So we did say that stage 1 in the diagram is what? Is meiosis. Then number 2, identify the error. It's meiosis 1. Remember, not just meiosis, meiosis 1, because that is how we lose marks, grade 12 learners. We forget to mention with meiosis, it is very important for you to say whether it is 1 or it is 2. So in this case, stage 1 is meiosis 1. Now the next question says, identify the error that has resulted in ovum R. So we're looking at ovum R, and we did say ovum R has 23 plus 1, so it means there's 24 chromosomes there instead of how many? Of 23, because we can now see that this is from a human cell, because we are talking about 23 chromosomes. We are not talking about any other different number, but 23. So the error that has occurred in ovum R, it's what we call what? Non-disjunction, the failure to separate. So note, we are not saying the error is Down syndrome, but we are saying the error is non-disjunction. And it is that failure to separate that leads to Down syndrome. Again, only where in human beings. We talk about Down syndrome in human beings. So we must be very careful when we answer this question. So we said the first answer was meiosis 1, then the second answer is non-disjunction. Then third question says, how many chromosomes are there in the diploid cell? So a normal diploid cell, or a diploid cell, will have how many chromosomes? 2. So this is the diploid cell that they are referring to. I did say there's 44 autosomes, which are your normal body chromosomes, and then we have 2 gonosomes. The gonosomes, remember, those are the sex chromosomes. Those are the ones that determine whether a child will be a boy or a girl. So there's 2 according to the diagram. And then the next question says, if ovum S, so ovum S is this one that has 23 plus X, so it has 24 chromosomes in other words, is fertilized by a normal sperm, what will be the number of chromosomes in the zygote B? So we have this one, ovum S has how many? It has 24. And if it is fertilized by a normal sperm cell will have how many? 23. So 24 plus 23 results in what? In 47. So our answer here is going to be 47. So the answer is that the zygote that will be formed will have how many chromosomes? 47 chromosomes. So that's the answer. Now moving on. What is the genetic disorder that will result? Okay, the answer is already there. The genetic disorder is Down syndrome. So the reason why we chose this activity, we wanted to highlight 2 things. If you look at question number 2 said, what is the error? If you look at 4.4b, it says, what is the genetic disorder? So guard against answering these questions incorrectly. What causes Down syndrome is non-disjunction. Non-disjunction is the failure of the chromosomes to separate. When exactly? In anaphase 1 or in anaphase 2. And then if this happens on chromosome number 21 in a human cell, it then results in this genetic disorder, which is called Down syndrome or trisomy 21. So let's look at more questions now that you understand what is going on. So the next one says, study the diagram alongside and answer the questions that follow. So from what we did in part 1, we all know that diagram 1 represents what is called a karyotype. A karyotype, it shows the layout of all the chromosomes in your cell. So if we look at this diagram, we can see that these chromosomes are in pairs. So these are homologous. All of these are homologous chromosomes are in pairs. So in other words, what is represented here is a cell that is that is diploid, because the chromosomes are in pairs. If we count them, we'll come up, if it's a normal one, we'll come up to 46. But the pairs are how many? Are 23. So this is what we have. Another thing, if we look at the last 2, the gonosomes, remember the last 2 are the gonosomes, last pair, which is 23, and then the rest are autosomes. If we look at a gonosome, we have a long one and a short one. So because they are not the same luckily, in this case, we are told that this is X and this is Y. So we know that what is represented here is a male. So then what else can we pick up from this diagram? All of them are in pairs going down, but then when we get to chromosome number 21, we can see that there's how many chromosomes there? There's 3. So already, because of everything that we've mentioned, you know now that this is the diploid cell, so it means number 1, fertilization has taken place again. So probably this is a zygote, or it is taken from the person who has the disorder, because there's how many pairs on, how many chromosomes on chromosome number 21? There's 3. So fertilization has taken place here because there's 3. And then this is an individual that suffers from Down syndrome. So now let's look at the questions again. What is the type of the diagram called? We did say this is called the karyotype. So that is the first question. So this, yes, our answer is karyotype. And then what is represented in the diagram? So what does the karyotype represent? A karyotype represents chromosomes. So these, all these that you see here from number 1 up to number 22 and the last 2, these are called the chromosomes. So what is represented in the diagram is the layout of what? Of the chromosomes. Then 2.3, name the syndrome that the individual is suffering from. We did say because of what we see on chromosome number 21, there's an extra copy. So there's 3. So this syndrome that is shown here is Down syndrome or trisomy 21. Then the next question says, what gives rise to the syndrome? Again, what gives rise to the syndrome is non-disjunction. It's what? The failure to separate. So you see, we've done 2 activities already. The first activity, the question was, what was the cause? What does it result in? We did say the cause, it's failure to separate, non-disjunction, and it results in a syndrome or a disorder called Down syndrome. Again here, name the syndrome. It's Down syndrome. What causes Down syndrome? Failure of the chromosomes to do what? To separate. And remember now, they fail to separate, and then if that chromosome, or if that ovum or a sperm cell has an extra copy and it fuses, or it is fertilized by another normal cell, and then the individual will have an extra copy on chromosome pair number 21, they will have 3 instead of 2, and that is Down syndrome. So another thing that we need to be careful of, remember, Down syndrome only comes after fertilization. So at the end of meiosis, there will be that cell which has an extra copy on pair number 21. So instead of having 23, they will have 24. But we cannot say that it's Down syndrome until fertilization has taken place and a zygote is formed that has 3 copies on chromosome number 21. Then describe how the syndrome is caused. This is exactly what I've just mentioned now. How is it caused? Is that a normal cell or a normal gamete of 23, this is a normal gamete, fertilized a gamete that has how many chromosomes? That has 24. So then after fertilization, a zygote then has how many? Has 47. And the 47 on pair number 21, there's an extra copy. So there's 3 chromosomes on chromosome pair number 21, because pair, they're supposed to be 2. But in this case, they will be 3. So they're not forming a pair. So let's read the answer. So here, during anaphase, that is where you start. During anaphase, chromosome pair 21 did not separate. So they all went together to the other side. And then this led to one cell having 2 chromosome number 21 instead of 1. So it started with anaphase where there was a failure to separate, and then led to 2 chromosome number 21 instead of 1. Then what happened after that? When now this gamete that has 2 on pair number 21 fused with a sperm cell, resulting in the zygote, had how many? 47 instead of how many? 46. And then further you say there are 3 chromosomes, 21 instead of how many? 2. That is how you get all the marks. Please take note, this answer did not just stop at saying during chromosome 21 or during anaphase, chromosomes did not separate, therefore there was an extra copy. It did not end there. You describe, so you provide the sequence of events that will lead to now the disorder called Down syndrome, exactly as you were taught, exactly as they are in your books. So then this is the answer for activity 2. So moving on. Remember, we are doing as many questions as we can until you understand. Then activity 3. Activity 3 says the diagram represents the distribution of chromosome pair 21 as it appears in gametes at the end of meiosis in a human male. So we see human, we see chromosome pair 21, so we can all conclude that this will lead us to what? To Down syndrome. But if there was no mention of pair number 21, no mention of human cell, but we are still talking about non-disjunction, we cannot now all of a sudden start talking about Down syndrome when we were not guided by the question. But this question is telling us that we are going towards Down syndrome because we are talking about pair 21, we are talking about a human male. So we're looking at the diagram. Diagram has 4 cells. So this is obviously at the end of what? Of meiosis, because we have 1, 2, 3, 4. So 4 cells are formed at the end of meiosis. But if you look at this cell, the first 2 seems to have an extra copy. The first 2 have an extra copy. And then the other 2, they look empty. But because we are told that this is a human cell, so it means the first 2, we have 23 plus 1, 23 plus 1, and then these 2, instead of having 23, we have 22, and here we have how many? 22. So this is how it looks like. So based on what we learned earlier, remember I said important to analyze the diagram first before you answer the questions. So if we look at this, we can all agree that what resulted in this is because of anaphase. It happened in anaphase what? Anaphase 1. This is what you need to remember. When non-disjunction happens in anaphase 1, where the homologous pairs move together, it results in 4 cells that are all abnormal. None of the cells will be normal because 2 will have an extra copy and 2 will have one less copy. Whereas if it happens in anaphase 2, 2 cells will be normal, 1 will have an extra copy, and 1 will have one less copy. So now the question is, explain why the diagram represented by C and D do not have any chromosomes. It's exactly what I said, that during anaphase 1, homologous pair of chromosomes did not separate, and they failed to separate, therefore they moved together to the new cell or to the cell that was formed at the end. As a result, the new cells that are formed had extra copies, and then the other cells had one less copy. So that is what has happened there. And failure of the chromosome to separate, which resulted in which is called what? Non-disjunction. So let's look at the answer. So due to non-disjunction or non-separation during anaphase 1, which is exactly what I said, 2 chromosomes, so the whole pair moved to one pole and none moved to the other pole. So that is what has happened here. That is why these 2 have nothing and the other 2 have 1 chromosome extra. So that's the answer. We've explained, we've mentioned the cause, or we've mentioned the statement and the reason. So the cause here is the what? It is the failure to separate. It's non-disjunction. That is the cause. And what is the effect? The effect is that if they fail to separate, then this is what happens. They move together to the different pole, to the whole pole, and then they lead to one cell having an extra. Then the next question is, let me just remove this part. Okay, I've erased everything. The next question is, if gamete A now is involved in fertilization, so this is gamete A. Remember, we said gamete A, according to what we know, gamete A has 23 plus 1. So it has 24. So if gamete A is involved in fertilization, describe how this may result in Down syndrome. So we have gamete A, I'm going to write this side. We have gamete A, which is 23 plus an extra copy. And then if gamete A fuses with a normal gamete that has how many? 23. Then it means we will have a zygote that will have how many chromosomes? 47. And because we were told that this failure to separate is taking place at chromosome number what? 21, isn't it? So then it means at the end, on pair number 21, there will be how many chromosomes instead of 2? There will be 3 chromosomes. So this is what we are looking at here. And then because there will be 3 on those chromosomes, then that is how then it results in what? In Down syndrome. So we explain now how Down syndrome occurs, what causes Down syndrome. It's when after fertilization of the normal and the abnormal cell, then extra chromosome 47, and then this results in Down syndrome. So again, so gamete A, like we said, has how many? Has 24 because there's an extra. And then when it fertilizes the normal ovum, which has how many? 23. And then the zygote will have 3 on position 21, or it will have 4. Then that is how you get your marks. So what we want to highlight here is that it is very important that when you answer questions, you write full sentences. Read the answer to yourself and read so that you understand, so that you can feel or see that it makes sense before you submit your paper, or be satisfied with the answer that you write. Okay, then the next question is, the diagram below represents 2 stages of meiotic cell division. 2 stages of meiotic cell division, and then we're going to look at the questions again. So this was taken from the last year's paper. We're looking at 2 cells, diagram 1, and we are looking at diagram 2. So with diagram 1, if you look at diagram 1, we can see that there's a nucleus that is disintegrating. We have homologous chromosomes that are pairing up. We can safely say they are forming bivalents because they are lying next to each other. And then we can see what is happening there at A. Crossing over is taking place. Genetic material is being exchanged. We can see that the nucleus is disintegrating. We can see that the centrosome has split into 2, forming the centrioles, and the centrioles are at the poles. And we can see the spindle fibers that are being formed there. So we can conclude that diagram 1 represents prophase 1, remember. And then diagram 2, now the pairs are lining along the equator. They are still in pairs, but now they are at the equator of the cell. So we can safely say that diagram 2 represents metaphase. So looking at metaphase there. Then we have D there that is circled. So now let's see again. Okay, the labels, we have the homologous pair there. B is the centriole. C is the spindle fiber, and D also represent those pair of homologous chromosomes. So name the structure B, we did say that's a centriole. Name the structure C. Structure C is the spindle fiber. Identify phase represented diagram 1. The phase in diagram 1 is prophase 1, and we did mention the reasons. So this question was done. If you did tune in last week, in the last week's lesson of Life Sciences Meiosis Part 1, this question was done, but the last part of the question was not done because it linked to what we've just completed today. So now, the question says, describe the result at the end of meiosis if chromosomes at D now. So here, we're looking at this, the focus is here, failed to separate. So we have these chromosomes. If they fail to separate, we are asked to describe the result at the end. So what will be at the end of meiosis 2, in other words, if these two decide to go together to move to the pole and become part of a new cell. So first of all, we need to figure out this is meiosis 1. This is metaphase 1. So this failure to separate that we are talking about here will be failure to separate where? In anaphase 1. So remember that, what did Agnes say about failure to separate in anaphase 1 and failure to separate in anaphase 2? The results are not the same. So if they fail to separate in anaphase 1, we already know that at the end, yes, we know there will be how many cells? 1, 2, 3, 4 cells. But these 4 cells, now, remember, this we are just told that it's the 2-stage of meiotic cell division. There's nothing that tells us that this is a human cell or this is we are not told about the number of chromosomes. So whatever we use to answer the question, we'll refer to the number of chromosomes that are here. So we started with how many? We started with 4 pairs. So there's 4 pairs. There's also how many here? There's 4 pairs of chromosomes. That means 1, 2, 3, 4. So at the end of meiosis, in other words, there's 8 in each. So at the end of meiosis 1 here, if this was the normal cell, at the end of meiosis 1, 4 were going to be on one cell and 4 on the other cell. But at the end of meiosis 1, instead we are going to have one cell that will have 1, 2, 3, 4, 5, because these two are going to go together. And then the other cell will have 1, 2, 3. So this is end of meiosis 1. So then at the end of meiosis 2, it means we will have 4 cells. But out of the 4 cells, 2 are going to have how many chromosomes? 3. And the other 2 are going to have how many? 5. Because this has taken place in anaphase 1. So none of these cells are normal. Because if they were normal, all of them were going to have how many chromosomes? 4. So 5. 2 have 5 and 2 have how many? 3. So now describe the results. So if D fails to separate, the end result will be 4 cells will be formed. 4 gametes, 1, 2, 3, 4 gametes will be formed. And out of the 4 gametes, 2 will have 3 chromosomes each, and 2 will have 5 chromosomes each. We're going to leave our answer there. This question did not ask us about the syndrome. This question asked us what will be the result. What are we going to find at the end of meiosis 1? And this is what we are going to find. So let's look at the answer. 4 daughter cells will be formed, and these are our daughter cells 1, 2, 3, 4, and of which 2 are going to have 5 chromosomes each, and the other 2 will have 3 chromosomes each. So that is the results. So then why this question? With this question, we want to show that not all questions about non-disjunction want you to talk about Down syndrome. In this question specifically, we were not asked to discuss anything related to Down syndrome. The examiner wanted us to tell him or her that how many cells will be there at the end and how many chromosomes will each cell have. That is all. So you should be careful when you answer questions around non-disjunction and Down syndrome. It is not always about Down syndrome. It is, remember, failure to separate, and then the 4 cells or 4 cells that are formed at the end might have an extra or might have one less. That is very important. Unless the statement clearly says to you, this is a human cell or this is a sperm cell of a human cell, or you are given the number of chromosomes, which is 23 or whatever, then you know that there's Down syndrome. Here, we're not told about the number. So our answer cannot talk about 23. We cannot now say at the end of meiosis, there will be 4 cells, 1 will have 23 and 1 will have 22, because we're not told about 23 and 23. Our answer is based on what we see in this diagram. So then these are the questions then on meiosis part 2, non-disjunction, and I hope that with these questions, we have clarified most of the things that you still needed answers to. So now we're going to look at the one last more before we go to through the last part of this session. So the diagram below shows the part of abnormal human karyotype, and here we know it's human. So how many chromosomes are we expecting? 23. So we are shown number 21, number 22, number 23. And as good learners that we are, and already because your teachers have explained here now, you can see that, okay, 21, instead of having 2, it has how many? It has 3. And then the rest have 2 and 2. Again, the second thing that you will notice is number 23 has 2 chromosomes which are not the same. We have a big one and a small one. So the big one obviously is the X chromosome and the small one is the Y. So this is the male, we know. Now, how many autosomes are shown in the diagram? Remember, the autosomes are all the other body or chromosomes except the sex ones or the chromosomes. So it's 1, 2, 3, 4, 5, because these are the sex chromosomes. So the answer there is 5. Name the type of chromosomes represented by 23. The X and Y, we said those are the gonosomes or sex chromosomes. Name the disorder represented. The disorder is called Down syndrome. We are naming the disorder. The disorder is called Down syndrome. Process during anaphase of meiosis that resulted in this disorder, the process is non-disjunction, the failure to separate. And then the last question, state the gender of this person. This person is the male because the 23, pair number 23 does not look alike. The other one is big, the other one is small. So X and Y. Okay. Then lastly, according to the exam guideline, you are supposed to compare meiosis and mitosis. Remember, we did mitosis in grade 10. So what are the similarities between mitosis and meiosis? We know that number one, both of them are type of cell division. So they are cell division processes. Both of them they require DNA replication to take place. And both of them have phases, prophase, metaphase, anaphase, and telophase. So we do know that. So these are the similarities. We know before mitosis can take place, DNA replication must take place. Before meiosis can occur, DNA replication must take place for the replicated and the unreplicated chromosomes. And then lastly, the differences between mitosis and meiosis, very important. Questions will be draw or tabulate the differences between mitosis and meiosis. What do you do as a grade 12 learner? You draw your table, you write your headings. We have our headings here, mitosis, meiosis. So what are the differences? Mitosis occurs in all the body cells, whereas meiosis, it takes place where? In the sex organs, because it results in the formation of what? Of gametes. Mitosis is only one division. Meiosis, it's 2 divisions. That is why we have meiosis 1 and meiosis 2. Mitosis results in the formation of how many cells at the end? 2. Whereas meiosis results in the formation of how many cells at the end? 4. And then with mitosis, the 2 cells that are formed at the end, they are identical to each other or to one another, and they are also identical to what? To the mother cell. Whereas in meiosis, the daughter cells are genetically different from each other, and they are also different from the mother cell. Why? Because of prophase. Remember, in prophase 1, crossing over takes place. There's the chromosomes, they exchange genetic material. And then 2, in metaphase 1 and metaphase 2, we talk of the random arrangement of chromosomes along the what? The equator. All of that brings about genetic variation. That is why at the end, the 4 cells that are formed will be genetically different from each other. And then the other one is chromosome number remains constant with mitosis. So with mitosis, if we've started with a cell of 46, at the end of mitosis, the new cells will have 46. Whereas here with meiosis, the chromosome number is halved. So if we've started with 46 here, it means we will end with cells that have how many chromosomes? 23. Remember last week when we did the importance of meiosis, we said it is to make sure that the number of what it is, it prevents the doubling effect of chromosomes during fertilization. Because if this does not take place, it means that a 46 cell will fertilize another cell which has 46, and this will result in 92. And if that's the case, that is no longer a human being, it is something else. So to make sure that this species of human being, it continues, meiosis will take place so that the number is halved, so that when fertilization takes place, then the number goes back to 46 again. And then mitosis, there's no crossing over, there's no exchange of genetic material. That is why the cells at the end are identical, and they are identical to the original cells. Whereas with meiosis, crossing over takes place, which results in what? In this variation that takes place in the gametes. So now we have come to the end of today's lesson. So just for a recap, part 1 of meiosis last week, you did the introduction, you learned about replicated and unreplicated chromosomes, and then you did the phases, all the phases, meiosis 1 and meiosis 2. Then today we took you through the disorders, abnormal meiosis. If abnormal meiosis take place, what does it result in? Especially in the what? In the human beings. So if you now go in an exam guideline, tick off all the points that we have covered. Then if you still feel that there are points that were not covered properly in those 2 sessions, then you can just ask your teacher to go back and explain those sections to you. So that it's very important that you understand before we move on. Because remember, later in reproduction, your teacher will be referring back to meiosis. Later, when you do evolution or genetics, before you even get to evolution, genetics, we will be referring back to meiosis. When you do evolution, talking about genetic variation, we will be referring back to meiosis. So you need to understand this topic clearly so that you can now add on the new information that is going to come throughout the year. So we have come to the end. We are wishing you all the best for the year. Tune in our next week's lesson, which will be focusing on the first part of reproduction, which is the reproductive strategies. It will be the same time, same place, 2:30, same place next week. So this is the end of today's lessons, and thank you very much for your attendance.